in this project we want to do a different way. We want to go with the JAX-RS 3.1, a new Java SE Bootstrapping API. What most of you would expect from writing JAX-RS service is that we write just a resource file, and that resource file is possibly accompanied by an application or by some components, and then we put it on an application server, and the application server will seek all that files and start the application. So as I said, we won't have an application server. The question is, how can we do this bootstrapping? How can we write an application that starts a web server essentially and puts the implementation of JAX-RS on a web server and puts our application in it and finds our application and starts the application? That sounds like a lot of work and like being complex. So we could think about using some native code from Jersey to do that, which I have done often in the past. But in this project, we want to do a different way. We want to go with the JAX-RS 3.1, a new Java SE Bootstrapping API. Well, that's a complex name, sorry for that. Yes, there is a new API in JAX-RS 3.1 that allows us to bootstrap such JAX-RS application without an application server and without a framework, just by, well, giving it some kind of standard code, no vendor-specific code. And we want to go into that right now. So how can we start such an web server and JAX-RS implementation and application on top? There is a new API, as I said. It's called the SE Bootstrap. And why can't I find it? Because I have not yet added JAX-RS at all. So we should do that first, certainly. So we need JAX-RS as a dependency here. And besides JAX-RS itself, we certainly need an implementation, and I will use Jersey for that. So we can see here, this is the version of JAX-RS I'm using, which is 3.1.0, the first one coming officially with the Java SE Bootstrap API, and I want to use Jersey version 3.1 M5, which is the latest Jersey at the time of recording. And to actually include the dependencies, we need a lot of stuff. I'm pasting it here because writing needs too long, and I will go through that with you. So first of all, I've added a dependency management section, which is good for loading the Jersey BOM, which is a trick to not always have to write the same version number again and again. It makes my POM file a bit more shorter and more concise. And you could do that in Maven with the scope import. And what I need next is the actual dependencies. So I have a dependency for JAX-RS here, which is the API itself. It does not bring any implementation with it. So this is what I use to compile against. When I'm writing my application, I will only use classes and interfaces from this one. When we want to run the application, then we need an implementation. So as we don't have an application server that brings it with it, we have to provide the implementation for JAX-RS, and as we're using Jersey, we have to write down the dependencies for Jersey that we will need. So why are the multiple dependencies? Because Jersey is highly modular. We can select all the technologies and support APIs that we want to have in our application from Jersey. So we strip down the number of jars that we load. We start with the Jersey server, which we need because we want to run a server. Then we need an injection framework. For now, we're going with Jersey HK2. Then we have a container implementation for Jersey, which actually is the driver for HTTP server. So as we want to go with Netty under Jersey, we have to provide this container implementation, which is a Jersey container on top of Netty's native API. And later we possibly want to use the Jersey client, so we can do JAX-RS client calls too. Not planning this now, but maybe I need it later, so let's just add it. And we have also an implementation for the Jersey client on top of the Netty API. So we could get rid of this now, but it's not that much code. Let's just keep it. So now, if you wonder why I'm getting these red lines, it says it cannot find this version of Jersey. So why is that? Because this is not published yet. I'm doing a trick. I'm adding a repository to my POM file. That's not the best way to do it actually, but for now, until Jersey is actually published, it's okay for this demo. So I put it here, doing a bit pretty printing, and it should be fine. Yeah, doesn't complain. So let's do a clean package to see if it works. Yeah, and it puts everything into the jar file. So if you wonder how big that file is getting, let's look at that. We now have, wow, that's really interesting. This was the original code that we wrote, and when we pack everything into the jar file, including Jersey, then we have a really big payload. This is the point where normally you start to get rid of that jars that you don't use. So let's do that and see the difference. Let's do it again. It's not much changed. So what you could do now with the Maven Shade plugin is to actually tell the Maven Shade plugin to optimize the content. You can do that. I actually won't do it just for your interest. Sorry. You can do that by the configuration option minimize jar and tell it true to really optimize, and let's see what happens. So it's much smaller now, but everything we need wouldn't work. The reason for that is that the Maven Shade plugin is not perfect in optimizing, and he throws away too much. So essential classes are missing. The point is, not everything that you need to load from those jars can be seen by a compiler. So for example, if you do loading of a class by its name and the name comes from a string variable, the content of that string variable is not predictable at compile time. So this kind of dependency is not seen, so that class would not be there. And as this class wouldn't be there, all these dependencies wouldn't be there too. So if you want to make this work, we have to provide a separate episode of this tutorial. We want to go into that later. We can correct it. It's not very complex, but it's just too much for now. So I remove that again and package it again to be sure that it still works. Yeah, it's huge again. So we want to do something more interesting with JAX-RS than just packing Jersey into a shaded jar. So let's go on with the Java code. So here we have a JAX-RS version of Hello World. What I did actually is simply that I have added the server bootstrap code for Java SE. So if you don't know this class, this is new to JAX-RS 3.1. It allows us to start up an implementation of JAX-RS, providing its own HTTP server. And the sole thing we need to provide is an application instance. And the application instance is simply created with new from an original JAX-RS application as you know it. I have everything in inner classes just for sake of this video to make it easier for you to follow the source code. In a professional application you certainly would have more packages and classes. So another nice thing you can see, by the way, I have used this new set.off operation that you can do in modern Java, which more or less is equal to the collections.singleton set method, but it's easier to write and easier to remember because, for example, if you want a list, you could just do a list of or a map, you could use map of and so on. So this .off pattern, this is really quite nice. So what we do here is that the application says I want to use a single class, and the single class is the Hello World resource class, and you know a resource class quite well. What we do is we have moved the Hello World from the main method into the greeting method, so we return Hello World as a greeting. If we do get on the root path, and to guarantee that we are on the root path, I also added an application path root because the specification is not that clear about where the root path is for a Java SE application. So for safety, I added both the root path of the application and the root path of the root resource. So now let's just start it and see what happens. And we see, well, it has booted and there's nothing else, and it says the service is available on port 8080, and we can open the browser and we can see Hello World. So the application actually is working.